In this video, we're going to talk about topic 10.3, the nth term test for divergence. So we're going to answer the question how to use the nth term test by divergence, and by the end of the lesson, you're going to be able to say I can determine the convergence of a series with the nth term test for a divergence. So if we look here at this theorem, so it says that the limit of the nth term of a convergent series. So we know if the series converges, then its limit as n approaches infinity equals 0. And it seems rather intuitive that a series cannot possibly add to a finite sum unless the terms themselves approach 0. But it's also important that the contrapositive of this is true, meaning that if I switch around my if and my then statement a little bit, that the limit as n approaches infinity of the series of a sub n the series is not equal to 0, then the series diverges. There's a few things though that we can't determine from this. So this is the nth term test for divergence that we're going to be using. So look over here at the note on the left hand side. It is important to note that if the limit as a sub n is equal to 0, the series does not necessarily converge. It just means that the nth term test is inconclusive and we'll have to use one of our other tests. So for today, it's inconclusive until we have more tests, okay? We're also going to start seeing some more factorials. They're a little bit trickier to deal with because they don't play super nicely with calculus. And we'll see one here on what the expansion of a factorial does to our series. So determine the convergence and divergence of each series, and really we're only going to be able to tell if it diverges. So I'm going to start by putting my series into my limit as n approaches infinity of n over n plus 1. And in this case, we notice that we can either use L'Hopital's rule, or we notice that our exponents are the same. So when our exponents are the same, we know our limit as we approach infinity is just the ratio of the coefficients in front, which would be 1 over 1, or just 1. So since we got something that is not equal to 0, we know that this diverges. So this is therefore this diverges. All right, in this next one here, we have the limit as n approaches infinity of 1 over 3 to the n over 2 to the n. I would probably think about L'Hopital's rule, maybe not even that. This is, when I'm putting infinity in, that 1 really is not going to matter. So I would probably look at this as the limit as n approaches infinity of 3 to the n over 2 to the n. Which I could rewrite that as the limit as n approaches infinity of 3 over 2 to the n, which when I put infinity into that is just going to equal infinity. So therefore that's not equal to 0. So this one has to diverge.